Okay, so what we're going to look at here is the visual representation of what we've just been doing. So you'll notice we're jumping from exercise 2B, Andrew, to 2D.4. All right, and the reason we're doing that is because in 2B we learned the discriminant, and now we're looking at what's the effect that that has on the graph. How can we relate that to the graph of the quadratic? So all we're going to do is we're going to start with this quadratic, determine the nature of the roots, and then view that on the graph of the quadratic. So what we're going to do first is to find the discriminant. So we'll identify the values of A, B, and C. We'll evaluate the discriminant, and it's going to be B squared, take 4 times A times C. So we'll have 4, take away 4, which is 0. The discriminant is 0. This means the graph has one root. This graph has one root, one double root, okay? So it's touching that graph once. Now, what we'll do is we'll recap how we can use our calculator to confirm that this is the case. So if we can pull our calculators out, we'll go to the graph mode. So your calculator is your friend. You want to use it when you can. So we'll go to graph mode. We're going to graph the function x squared, take 2x plus 1. Alright, set our V window to standard. So my assumption is we're pretty familiar with all of these skills. And this is what we're going to observe. Alright, it looks like this. Now we have one root. We can G-solve that root. We can solve it via factorization and solve forth. If we press G-solve root, it's going to tell us the x value is 1. We could find that via factorization. The y-intercept occurs when x is 0. The y-intercept is also positive 1. Okay, anyone got an issue? I'll come around and see. We'll deal with these issues now, and then we'll shift on.
The roots?
Oh, the function, x squared take 2x plus 1. Yeah, that's what we're talking about there. Oh, that's very bizarre. X squared take 2x plus 1. Well, I think you've got a different setting turned on. I don't know, look at yours.
Yeah, but what else that?
We've all got some setting on that's calculating. That's very bizarre. We'll have a look. Okay, let's shift on. Looks like we're all able to G-solve it, but we're having some rounding error here, so I'm going to have a look at a setting that you guys have. Okay, so that's it for the first one. Look, the discriminant told us there's one root. When we graph it, we observe one root. It's only touching the x-axis once. So our calculator we can use to support us. Let's move on to the next one. Here we have A is positive 1, B is 3, C is 4. Alright, A is positive 1, B is 3, C is 4. So we'll find the discriminant, B squared, take 4AC, it's 9, take away 16, minus 7. Alright, so the discriminant here is negative, which means there are no roots. In fact, this is going to be a special case for us. Whenever we have a negative discriminant, we have two possibilities. It's either positive definite, where it's completely above the x-axis, or negative definite, where it's completely below the x-axis. In our circumstance, our A value is positive, so that means the graph is going to be positive definite. No roots, and the graph is positive definite. Let's observe that one now in the graph mode. We're going to graph this function, x squared plus 3x plus 4, over the same interval. Alright, y-intercept will be positive 4. What we see here okay, from the graph mode is that there are no roots. There's no roots because it doesn't cross the x-axis. It is completely above the x-axis. And so this is the special case that we call positive definite. If it's completely above the x-axis, it will be positive definite. So that occurs when the discriminant is less than 0 and a is positive. The negative definite occurs when the a is negative. Alright, so all we're doing in this exercise then is using our calculator, drawing those graphs, and using the discriminant to identify the relationships with the roots. So let's dedicate our efforts there.